Okay, so we now come to the second of our pair of talks. Is the universe designed? That was probably somebody switching off their mobile phone. We had a talk by Stephen Law, Dr. Stephen Law, just before the tea break on an atheist view, and we're about to have Dr. Rodney Holder give a theist view in this pair of talks. And remember, this is a series which is considering whether science and religion narratives across various different disciplines are different when the narrative comes from a theist or an atheist. So it's been a very interesting set of talks so far, so we look forward to Rodney's contribution now. I'll just tell you a word or two about Rodney. He's the course director. He's set up this course. He is a physicist by training, did a PhD in Oxford on astrophysics, and then worked for the Ministry of Defence on operational research for 14 years. Then he went back to university, got a degree in theology, became a vicar, and then latterly moved on to be with the Faraday Institute as the course director since 2006. So Rodney probably knows personally more people working in science religion in the world than anybody, because he's asked each one of them to do something for him. Okay, so over to you, Rodney. Thank you very much.
Well, thank you very much, Bob. Just to lay my cards on the table, I am a Christian. I had a conversion experience not long after coming up to Cambridge when I was 18. And after this long career, as Bob says, I became ordained in the Church of England and I worked in parishes. So what I intend to do is to talk really about the fine-tuning argument, about cosmology. We've had a brilliant talk there which has raised in a big way, I think, the theodicy issue, and certainly that needs to be tackled in some way. I mean, theists need to have something to say about that, that's for sure. And maybe you'll come back with questions or for the panel about that. It might occur incidentally, but the main area I'm going to talk about is the fine-tuning argument. Is the universe designed? And so I'm going to look at the Big Bang Theory, talk about just what this fine-tuning is, to ask the question, is there really anything to explain? That might engage with some of the questions Stephen Law raised, and to look at what possible explanations there might be. Brief history of cosmology as to how cosmologists have tried to explain the fine-tuning. What Christians think about multiverses. Some are very favourable, and I'll have a word or two to say about that, and then some problems with the multiverse idea. Okay, and compare the explanations. Well, my starting point is the Big Bang. This picture shows, of course, Albert Einstein on the right, as you will recognise, and the person on the left is Georges Lemaitre, who is the father of the Big Bang. And immediately you can see there's a science and religion issue here. Lemaitre was a Catholic priest and a very eminent cosmologist, and he solved Einstein's equations, applied to the whole universe, and came up with an expanding universe solution in 1927, and then in 1931 a real Big Bang universe which originated in a singularity. He called it the primeval atom. Fred Hoyle, who was an atheist, dubbed it the Big Bang because he, like other atheists, didn't like the idea of the universe having a beginning in time because they thought that might need God then to create it. Well, Lemaitre was proved right. The expansion was observed by Hubble, and Hoyle put it forward with colleagues an alternative, the steady state theory, whereby the universe was eternal. But the Big Bang theory was confirmed by the evidence of the cosmic background radiation observed in 1965 by these two characters, Penzias and Wilson, for which they got the Nobel Prize. Now it seems to me that cosmology raises two fundamental questions, which take us beyond the science into metaphysics or theology. I've already hinted at the first, this idea of the beginning, and the second is the fine-tuning, the way the Big Bang seems apparently to be set up in order to give rise to life. Now that latter point is much more relevant to the design argument. I'm going to focus more on it. I will say a word or two about the beginning, the temporal beginning. Stephen Hawking is another person who is troubled by the idea that the universe has a temporal beginning, and he's proposed imaginary time in order to try and avoid it. It's imaginary time in the sense of complex numbers. So time becomes like a space dimension. Well, interestingly enough, at Stephen Hawking's 70th birthday celebration, this man, Alexander Vilenkin, reiterated something that he had already proved with colleagues, namely singularity theorems, which show that really a whole wide range of model universes have a singularity. In other words, a temporal beginning. You can track back the history of the universe, whether it's a chaotic or inflation type universe, whatever. Colliding brains, BRANES, you know, these kinds of universes go back to ultimately to a singularity, and Vilenkin says that all the evidence we have shows that the universe had a beginning. And as I say, that's troubled atheists. It's not a problem clearly for theology, and one could build maybe an argument from God from that. But I don't particularly want to say too much about that. I want to take us back to St. Thomas Aquinas just to comment on that. He thought that we can neither prove nor disprove by reason that the universe had a beginning. He said, by faith alone do we hold, and by no demonstration have we proved that the world did not always exist. Well, maybe, the 700 years on, or whatever, science is actually telling us that the universe did have a beginning. But for Aquinas, that's in a sense neither here nor there. What matters is, for understanding the beginning, is that he takes that from Revelation, that the world had a beginning. On the other hand, here's Aquinas again, to the answer, why is there something rather than nothing, he would say that only God can answer that. So that we're talking now about ontological beginning, about God being responsible for the universe, whether it has an infinite past or not. Why does it exist? And the reason is that God is a necessary being, and that the universe is contingent. It may or may not have existed. And so just to wind up on this sort of brief section on the temporal origin, or non-temporal origin, the case may be, of the universe, it's interesting that Hawking himself, back in A Brief History of Time, asked the question, what is it that breathes fire into the equations and makes a universe into the scribe? So Hawking certainly then seemed to recognize this more fundamental question, why is there a universe? We can have the most wonderful theory, most beautiful equations. Why is there a universe to which this theory applies? Okay, but the question I sort of tended to focus on myself, I mean, there are people who make an argument from the temporal beginning nowadays. So William Lane Craig is one, Robert Spitzer, the Roman Catholic, is one. I tended to focus much more on the fine-tuning, and this relates to both the initial conditions right back at the beginning, shortly after the Big Bang, which need to be just right to high degrees of accuracy for the universe to give rise to life, and the constants which go into the laws of physics. So we have really in the realm of a nomological explanation, in a sense, in terms of having laws and constants and initial conditions in order to describe the universe, but then we might be in the realm of an axiological explanation for why the laws take the form they do. So the constants determine, for example, the ratios of the strength of the various fundamental forces of nature, the masses of the fundamental particles, and so on, and they determine these laws and constants determine how various processes go or don't at different stages of the universe's evolution. And there are many, many examples, and I'll just pick out 3. At 1 second after the Big Bang, the mean density of the universe needs to be what it was to within 1 part of 10 to the 15. If it's smaller than it is by this amount, the universe will expand too quickly for galaxies and stars to form and for there to be any life in the universe. If it's greater than it was by this small amount, then the universe would really collapse far too quickly under gravity for galaxies and stars and life to form. And either way, you have a very dull, boring universe with no possibility of life. If we were to naively extrapolate back to the first 10 to the minus 43 seconds, the earliest time we can speak about the so-called Planck time, then an accuracy of 1 part in 10 to the 60 would be. Now, one of the most important elements for life is hydrogen, and if we didn't have hydrogen, then we wouldn't have water, and arguably couldn't have life. And in the very first couple of minutes, 2 or 3 minutes of the Big Bang, the weak nuclear force and the gravitational nuclear force need to be very well balanced, so that you don't get all the hydrogen turning into helium. You get some hydrogen, 25% of the universe is made of helium, and that was formed in the Big Bang through nuclear reactions when you had very hot conditions. To get not all of the hydrogen turned into helium, you need these forces to be very well balanced. And indeed, the production of the elements needs to stop shortly afterwards, so that you need the expansion rate to be just right to stop element production at that stage, and then to have it go on in stars later on during the universe's evolution. Bernard Carr, for example, notes that also that helium-burning stars wouldn't be long enough lived to have life develop on them, even if life could. There's another requirement that massive stars explode in supernovae to release the chemical elements that get manufactured in the stars, and that also constrains the weak nuclear force and the gravitational force in both directions. So this is a quite severe constraint. Then there is another nuclear force, the strong force, which binds nuclei together, and that has to be just right for carbon and oxygen to be made inside stars. To get carbon in the first place, and for all the carbon not to be burned into oxygen, to leave some of both. This is a very delicate balance that's required, because it's quite difficult to get carbon made, because it's made from 3 helium nuclei which have to crash together and stick, and the intermediate element, beryllium, is unstable. And the interesting thing about that third one is that this particular coincidence was discovered by Fred Hoyle, who said that a super intellect has monkeyed with physics, and there are no blind forces worth speaking about in nature. I think the extremely interesting thing here is that Hoyle was an atheist, a proponent of the steady state theory. He broadcast on the BBC in the late 40s, early 50s, describing religion as an illusion. But he was driven by his science to make this comment about a super intellect. And I think one of the things I want to emphasize is that this whole argument is one that's come out of the science. It's not theologians with a vested interest, as it were, coming in. It's coming out of science, and these sorts of coincidences were first discovered by Brandon Carter, who's an atheist, Martin Rees, who's an atheist, also Bernard Carr, who is more favourable towards religious belief. But but certainly these cosmologists had no religious motivation. And there are lots and lots of these kinds of examples. John Leslie, in his little book Universes, I think has about 30 or so of these kinds of coincidences, seeming coincidences. And Paul Davies, who was mentioned last night, makes the comment, like the porridge and the tale of Goldilocks and the three bears, the universe seems just right for life in so many intriguing ways. Right, so what I'd like to ask then, I mean, Paul Davies again is not a religious believer, but he certainly thinks that there's something going on here. But is there? So I think the first question to ask is there really anything to explain? If these various features, you might say, weren't exactly as they are, then we couldn't observe them, we wouldn't be here. We only can observe a universe which gives rise to our own existence. So doesn't it follow that we shouldn't be surprised to observe fine-tuned parameters which necessarily have to be as they are in order for us to exist in the first place? I think there are a number of, in fact, an argument rather like that was put forward by Richard Feynman, a great physicist, Nobel Prize winner, who gave a lecture one time in which he described how on his way to the lecture he'd observed a car in the car park with this Tennessee number plate ARW357. Can you imagine, says Feynman, of all the millions of license plates in the state, what was the chance I would see that particular one tonight? Amazing. But of course, and this is coming back to this discussion of probabilities we had earlier on, the a priori probability of that number plate is very small. That causes Feynman no problem because any other car would be just as unlikely and just as insignificant. Just happens that that was the car that turned up. And similarly then, according to some physicists and philosophers, we live in a universe in which the laws of physics are ordered in a particular way. If they were ordered differently in any number of equally improbable ways, we wouldn't be here. If we were to think, as some philosophers do, that life is insignificant, not of value, but just a bit of froth on the surface of a meaningless universe, then alternative universes are of equal value, if you like, to the universe that we're in, and it's the same position as observing that number plate in a car park. Thinking about this, actually, I was reminded that I had a school teacher called A.R. Wheeler, whose birthday was the 3rd of the 5th, 1907. Now, if that car had turned up in the school car park on his 50th birthday, then there would have been a different story. It wouldn't have been just entirely random. And similarly, there are other ways of thinking about whether something needs explanation or not, whether there is a better explanation. This is Richard Swinburne. He postulates a machine which shuffles 10 packs of cards simultaneously. And he tells his kidnapped victim that unless the machine produces and continues to produce for every draw 10 aces, the machine will alternatively explode so that the victim will be killed and no longer able to observe any draws from the pack of cards. But when the victim does observe successive draws of an ace, his conclusion is surely not, this just is purely random, but that the machine is rigged, rather than that there's nothing to explain, because he wouldn't be around if anything but 10 aces were drawn. think, a way of thinking about the fine-tuning too. Here's another explanation due to John Leslie. Here's another somewhat macabre example. That's a picture from the American Civil War. Leslie postulates a firing squad of 50 sharpshooters lined up against me. If they all miss, do I just shrug my shoulders and say, well, if they hadn't all missed, then I shouldn't be considering the affair? My still being alive requires explanation. Either all the sharpshooters deliberately missed, or perhaps there are immensely many firing squads at work around the universe, and I'm among very rare survivors. So I need to go into that kind of second explanation as well. That's equivalent to the multiverse kind of explanation. The prior probability that they would all miss on the basis of random chance is very low. But if there is something else at work, maybe they've been told deliberately to miss, or that there are lots and lots of firing squads going on, maybe that increases the chance that I survive. If I'm not sure, the many firing squads increases the chance that I remain alive. And that increases the chance of somebody being alive at the end of a firing squad. But I think that, having said that, there is a real parallel with the multiverse explanation. Just to hammer home this point, that there really is something to explain. Suppose I shuffle a pack of cards and deal them out before you, and suppose they come out. Ace, king, queen, down to 2 of clubs, the same for diamonds, the same for hearts, and the same for spades. Well, this hand is just as improbable as any other hand. Indeed, the chance of it occurring is 1 in 10 to the power 68. But it seems to me that there's a better explanation than sheer luck. I'm a card sharp. And if I were a card sharp, that would provide a very good explanation for me shuffling the cards and then just dealing them out and coming up with this hand. And the difference between the hand dealt and the vast majority of other hands is that one of these is meaningful. This one is meaningful. It displays a perfect pattern, and hence it makes sense to look for an explanation beyond mere randomness. And added to that, there is a straightforward explanation available. It seems to me that this isn't any old universe. The vast majority of universe configurations obtained by changing the parameters by the smallest amount are completely dead and boring. If you multiplied all the parameters by the same factor, then probably as Weinberg you get a similar outcome. But certainly within the whole parameter space, I would say that the vast majority of universe configurations coming out would be dead and boring, almost entirely devoid of meaning and value. This universe is shot through with meaning and value because, at least in one small part of it, it has produced creatures with rational powers to understand it and to appreciate its beauty, and with the capacity to exercise moral responsibility. The universe has, in some sense, become aware of itself. And many scientists, too, see objective value exhibited in the universe. And here's Paul Davies again. He says, my own inclination is to suppose that qualities such as ingenuity, economy, beauty, and so on have a genuine, transcendent reality, that they are not merely the product of human experience, and that these qualities are reflected in the structure of the natural world. Okay, well, why is the universe so special then? Maybe it was designed by God. There is a theological explanation, a theistic explanation, that God did set it up in this particular way with the intention of bringing about conscious agents with moral awareness and so on. So what are the alternatives to that explanation, given that it needs an explanation? And it seems to me that there are two main ones. And the first is to argue that we're wrong in saying that we can play with these constants, if you like. That there's only one set of physical constants. Maybe we'll come up with a theory of everything which calculates them all from sort of more fundamental principles. Maybe there's only one self-consistent theory of physics. And it's interesting that Einstein spent his later years in a fruitless search for a grand unified theory. What Einstein said, though, was what I'm really interested in is whether God could have made the world in a different way. So that doesn't obviously then preclude the existence of God. What it would do is make the universe, given that it exists, it would have to be as it is. Connected with that is also the aim of showing that what the initial conditions were doesn't really make any difference either. Okay. The second strategy is diametrically opposed to that. It's to postulate a multiverse. A multiverse is a vast, usually infinite, ensemble of existing universes, embracing the whole range of values of constants and initial conditions. And the idea is that if a multiverse exists, you can say, hey presto, given this vast ensemble, our universe with its suite of parameters is bound to exist, and we shouldn't be surprised to find ourselves in it because we simply couldn't exist in the overwhelming majority of universes which differ from ours in their parameters, to the values of their parameters to the smallest degree. Okay, well, strategy one then explains why the universe is like it is, given that it exists. Couldn't have been different. Well, if only one set of laws is possible, I mean, that's a pretty massive metaphysical claim, and rather more massive metaphysical claim than the one that says, well, okay, let's take our set of physical laws and say, isn't there a more fundamental version of those which calculates the constants? I think if that were the case, then one would have to ask, well, one would say that the problem, as it were, of the fine-tuning is removed from the parameters themselves into the law, and then the question would be, why is that law instantiated? And if it's the only possible set of physical laws, there is a massive puzzle too, and that is, why does it give rise to life? It would be puzzling that the only possible self-consistent set of physical laws give rise to the vast structure and order of the universe that we see, giving rise to almost anything else we could imagine. A single lump of rock somewhere, and nothing else. Coming to the second strategy, the multiverse hypothesis says that the universe certainly can be different, and indeed different universes actually exist. And it could be the case that the more universes you have, the more chance there is of getting one with life. But it seems to me that there's a pretty big puzzle here too, namely, why this particular multiverse as opposed to another. What we are now faced with is a choice of equations into which fire somehow gets breathed, and we have a choice about how many sets of equations give rise to universes and how many universes they give rise to. It seems to me that there's a big question here, what gives rise to these choices? One cosmologist, Max Tegmark, has proposed that all possible mathematical structures have physical existence. Now that would guarantee our universe's existence. But it takes us way beyond what physics can tell us, and I think most mathematicians and physicists think the idea doesn't make sense. You soon run into problems and paradoxes if you were to start to try and write down all possible mathematical structures. Incidentally, George Ellis, the cosmologist, has tried to do this in a couple of papers. And certainly there seem to be conflicts with what actually exists as opposed to what can possibly exist. For example, I can't simultaneously deliver a talk on is the universe designed from a theistic point of view and remain sitting home watching TV. Now, some copy of me in another universe could conceivably have taken a different course, but I couldn't do both things at the same time. So it looks to me as though not all possible universes can even be instantiated. So you have a choice, and what determines the choice? Now let me just give you a brief overview of the last sort of 40 years or so of cosmology, in which cosmologists have oscillated between these different kinds of explanation. Back in the late 1960s, a man Charles Misner came up with the chaotic cosmology program, according to which it didn't matter how the universe started off. Random starting conditions would soon give rise to a universe that is like ours, like our Big Bang universe, smooth and ordered and so on. And any, if you like, fluctuations would get smoothed out. But in a very fine paper, Stephen Hawking and a colleague, Barry Collins, showed that there was a probability of zero of that being the case, of starting from random conditions to getting an isotropic universe, one like ours that looks the same in all directions. And the universe needs to be isotropic, it needs to look the same in all directions in order for it to give rise to life. Otherwise you get shear forces which just wipe out the possibility of any development. Okay. Now, Collins and Hawking turned to a multiverse to solve that problem. And this, it seems to me, is the beginning of a pattern. Turning from a unique theory to a multiverse kind of theory. There are lots of ways of conceiving a multiverse, and I think Brian Greene in his latest book has 9 or 10 ways of conceiving a multiverse. There are ways of conceiving them. The main way I'm going to concentrate on is different regions within an overarching infinite space, and that's the most popular kind of way of doing it at the moment. Could be as successive expansions and contractions of a single universe, or saying that every time you make a quantum measurement, of course the outcome's uncertain, but maybe all the possible outcomes occur as the universe branches into lots of different branches. So there are lots of different ways of doing it. There's a slight problem here, though, because a simple probability on the basis of simple mathematics, the number of universes you'd expect to be just right, even if there are infinitely many on this scenario, would be infinity times naught, which is undefined mathematically. Now here's Alan Guth, who came along with the theory of inflation. So what happens is, very early on, the universe underwent a very rapid period of inflation, and then tailed off to this sort of smooth Big Bang. It looks like it's speeding up again at the present time. So that's good. And the idea of this rapid early period of expansion is that it forces the universe to home in on the fine-tuned value of the density parameter. The expansion rate ends up being just right after this sudden burst. And it solves a number of problems with standard cosmology. This initial burst, by the way, takes place in the first 10 to the minus 32 seconds from the very beginning of the universe. And there were a number of problems, certainly in the early days with inflation, not least that it itself needs fine-tuning. So this is an example in a way of my strategy one. You have a better theory which explains some of the fine-tunings, but which essentially moves the problem up a level into the theory. Why does that theory apply? And it itself needs fine-tuning. So, the answer to that then is, well, one goes towards a multiverse version of inflation. So we have these versions of inflation called chaotic and eternal inflation, whereby different regions of an overarching space-time inflate differently, and then you get chaotic inflation. Eternal inflation gives you universes branching off other universes, so you get universes bubbling up and out of this general background expansion. Okay. So you end up with a multiverse version of it. And then that doesn't entirely bring us up to date. This is Leonard Susskind. He is one of the pioneers of string theory, and this is a very clever theory which is all about what matter really ultimately is, not just point particles, but tiny, but only observational threshold bits of vibrating string. And it's a candidate for the theory we need to describe the first 10 to the minus 43 seconds from the origin of the universe 13.7 billion years ago. We need at that very early time a theory which combines quantum theory and general relativity, Einstein's theory of gravity. And this is certainly a candidate that's making a lot of running. The thing about it was, so that's trying to vibrating strings. The thing about it was originally, if you like, it was meant to calculate the values of the fundamental constants. It was meant to be a more fundamental theory. There are lots of parameters in the standard model of particle physics, and string theory was meant to be calculating. Even back in the early days, Richard Feynman, who I showed earlier on with the car number plate, argued that it wasn't making predictions and could really not be counted as science unless and until it did. It still hasn't, and Susskind now sees that as strength. And he says he's made the move again to the multiverse version of string theory, and he has written a book called The Landscape of String well, the subtitle is The Landscape of String Theory, the illusion of intelligent design. So Susskind certainly thinks that this does away with the need for design. The thing is that there are supposedly something like 10 to the 500 possible solutions of the theory, and if you combine it with the inflation model, that's what populates these the overarching space-time of all these different, if you like, mini universes. Except that they're large, they're infinite, but 10 to the 500 different versions. Now, there are lots, just a point about modern cosmology, there are lots of theories out there. One of the worries in cosmology is that theory is outstripping experiment and observation. And there's a famous physicist who made the comment that cosmologists are often in error but seldom in doubt, which I think has to apply, given that not all these theories can be right. But, okay, so from a theistic point of view, what would be a theistic take? Now, I'm a skeptic about multiverses. John Polkinghorne has been mentioned as a skeptic. The theologian Wolfhard Panda would be a skeptic. But there are some Christians, some working in science and religion, some theologians who welcome the idea. Arthur Peacock welcomed the idea. In fact, he said that what mattered for him was the potentiality of the whole ensemble of universes to produce cognizing subjects, not that of one universe in particular. So he'd be perfectly happy for a multiverse in principle. Now, the fine-tuning argument would still actually apply in this case, given that the multiverse itself would have to have the right parameters for one or more universes within it to give rise to life. Now, here's Robin Collins, a philosopher who certainly thinks that the fine-tuning is real and it needs explanation. And he thinks that he is not opposed to multiverses in principle either, but thinks that God would express his infinite creativity by creating a multiverse. And he thinks that a multiverse would be made more likely if there were a generator, if you like, a universe generator or a multiverse generator. If you had some theory of physics which in some sense naturally gave rise to lots and lots of universes. But, of course, he says that would still need design. The generator would need design. He makes the further point more recently that the universe is fine-tuned, our universe is fine-tuned for more than simply the appearance of observers. It's fine-tuned for embodied conscious agents with many more capacities than simple observers possess. And that really undermines the multiverse kind of explanation if we have these further capacities. And I'll come back to that point in a moment. Here's Don Page. He's an evangelical Christian, worked with Hawking, and he thinks that a theory without free parameters is actually a more elegant theory than one with lots of free parameters. So he would go for the string theory, M theory type multiverse, or quantum branchings and so on. He's in favour of multiverses. He's actually here, but if I've got my take on Keith correctly, then he has no objection to God creating many universes in principle, but God would only create universes which were better to exist than not to exist. So what's important to God is value. God knows what universes are possible to make and which would have preponderance of good over evil, and those are the universes that God would make. Okay. So, some problems, which I think there are for this kind of explanation of the fine-tuning. First of all, the physics on which the idea rests is highly speculative. The other universes are unobservable in principle. They're in regions which have no causal contact with each other. No signal from another universe can reach us in this universe. The energy regimes are unobtainable in the laboratory. The Large Hadron Collider will imitate conditions in the universe back to the first billionth, maybe trillionth of a second, but that's nowhere near 10 to the minus 43 seconds from the origin, when you need an accelerator the size of a galaxy. Martin Rees, interesting, in one of his books, describes himself as a cautious empiricist. In that book, he says he believes in physics from the first thousandth of a second from the origin. Now, of course, if you're late to all of this cosmology, that will seem pretty astonishing that we know what the physics was during the first, from about the first thousandth of a second. Well, we do, and we're tracking it back even earlier. But nevertheless, Martin Rees prefers a multiverse, even though he recognises that it's highly speculative and no more than a hunch. He prefers it because he thinks it avoids the need for God. There are curious problems when you get into infinity and infinite numbers of things. Mathematicians play about with infinity quite happily. Although I haven't said that, I think Cantor, who came up with the theory that transfinite arithmetic, went mad. But be that as it may, mathematicians today play about with infinities very happily. When it comes to the real physical world, you get into certain paradoxes, and Hilbert's hotel will be just one. You know, this hotel has infinitely many rooms, they're all full. A new guest comes along, what does Hilbert do? He scratches his head, he says, okay, I'll move the person in room 1 to room 2, the person in room 2 to room 4, the person in room 3 to room 6, and so on. Lo and behold, I've created infinitely many free rooms for new guests and so on. Now, I raised this sort of, there will be identical copies of me dotted around a multiverse in which some of them, a copy gives the lecture and others, the copy doesn't, and so on. Well, with all of these objections, I don't think that actually defeats the idea, but I think for me it would be metaphysically preferable to have and simpler to have an explanation which doesn't have those kinds of paradoxical features. And for that kind of reason, I think the multiverse isn't a simple hypothesis. Dawkins' razor would lead one to go for a simpler hypothesis of the one universe. And the question why this multiverse is left unanswered. Now, there is the question of a move away from predictability if one goes towards a multiverse. What's often said is that anything that can happen does happen sometime, somewhere in some universe. And there are many more disordered universes than there are ordered ones in the whole space of possible universes. It seems to me that we have to go for something like the Tegmark solution, the maximal multiverse solution. We have to go, if we're going to solve the fine-tuning problem with the multiverse. Otherwise, you still have the why this multiverse question. Everything. But then, if there are more disordered universes than ordered ones, there are all kinds of odd things happening in our laboratories which we would be tempted not to explain, except on the basis of a multiverse. Stephen Weinberg was mentioned, he comes into this next little discussion. One of the big problems today in cosmology is the cosmological constant, which, as has been already mentioned, Einstein introduced as it, but then later thought of it as his biggest blunder. Until recently it was thought to be zero. The Nobel Prize for Physics last year went to 3 cosmologists who have shown that it is not zero, that the universe seems to be accelerating. This cosmological constant is a repulsive force, essentially. And, however, there is a big problem. It's small, it looks like it's small and positive. It's called often dark energy. And the problem is that the calculated value, physicists think they know what it is, and when they calculate it, it's the energy of the quantum vacuum, they get a figure that's 10 to the 120 times too big. So why is the cosmological constant so small? Well, it couldn't be anything like that value for sure, otherwise our bodies would be blown apart to the opposite ends of the universe before I could sort of click my fingers. Now, this I think is an area where it comes closest to being explained by a multiverse. It can be within maybe a factor of 10 of what it is, and still be compatible with life, according to Stephen Weinberg, who was mentioned. You could still just about get galaxies forming and so on. It was a bit bigger. So we are a bit unusual, but perhaps not massively unusual, among the subset of universes that would give rise to life on that basis. Because what ought to happen, if we're in a multiverse, is the parameter values we observe ought to be sort of just about compatible with our existence, or typical values. There's disagreement about this, actually. Paul Davies thinks that, and even Weinberg thinks that the value of this thing lambda is a bit too special on this kind of criterion, but not massively so. But it does raise the issue of whether other parameters are too special, and I think the answer to that might be yes. For some of these multiverse models, you still need fine-tuning to get a multiverse. In fact, to get an infinite space, you need the mean density of the overall matter energy of the universe to be below this so-called critical value in order to get an infinite space. We can, let me see. We think now that inflation, the theory of inflation, is confirmed. There was this very rapid initial period of inflation. It looks like from the latest satellite data that is confirmed. But there's a small discrepancy in that data, and that could be explained if the universe is finite in size rather than infinite. Now that is a controversial model. We could be in a finite universe. We can see out to 13.7 billion light years. We could be in a universe that only goes out to 14 billion. That's the kind of overall size. And if we're in a finite universe that's small enough, then signals would bend back round and we'd see the same object in two different directions of the sky. And there's a model which is controversial. It's not confirmed, but fits the data indicating that. We don't know that. And in fact, we could just know if we were in a universe like that, but we can never know, as John Barrow says, if we're in an infinite universe, because we can only measure the density in our own little bubble. Now, Roger Penrose has posed a big problem for cosmology and for multiverse hypothesis. He imagines the creator looking at the space of possible initial universe configurations. I mean, the creator is a metaphor, of course, for Penrose. But here he is with his pin. And this is to do with the amount of order the universe starts off with. And Penrose says that the creator had of the order of 10 to the power 123 possible universe configurations to choose from, which would have the order and structure that ours does. This is basically the second law of thermodynamics. If I knock this glass off the table, it might well smash, water go all over the place. There's a direction to time. It starts orderly, ends up disorderly. You don't see water scattered, jumping up into broken glasses, glass coming together and so on, and jumping up onto tables. So the universe started off very, very highly ordered. But there's even a twist to this, because what we would expect to see, this goes back to my discussion of the cosmological concept, what we would expect to see if we were in a universe that's a member of a multiverse is just enough order for us to exist. And that would be something like a solar system surrounded by chaos, or surrounded by junk. And a solar system could be produced much more cheaply, still we want to have 10 to the 60 configurations, but by the random coming together of atoms. So what it looks like, because this, this is 10 to the 123, far bigger than 10 to the 10 to the 60, is that the universe started off much too special. So other parameters look like they're too special as well. They're not needed to be this special for life to arise. And you would likely observe certainly less special values in a typical member of a life-bearing member of a multiverse. Okay. Whereas these two fake universes has come up already. In fact, if you're in a multiverse, according to people like Paul Davies, John Varro, the philosopher Nick Bostrom, you would be much more likely to be in a fake universe than in a real universe, in a simulation than in a real universe. Because as soon as there's some civilization, then it will start spawning universes, and simulations are much easier to make than real universes, so we would be likely to end up as something like the film The Matrix, in a simulated universe than a real one. Well, that's an argument against that from, that's what we'd be likely to be, that there were a multiverse, according to these people. I'm not sure how seriously I take that one, but there we go. All right, so I think that when it comes to the multiverse, it doesn't answer why it's something like nothing. It's complex because you've still got this why this multiverse question. It doesn't explain why there should be life. This universe looks too special, and God does answer that question, and God traditionally, again as we've heard, is conceived as simple, and explains why there should be intelligent life that would have purposes and intentions for there to be such, and why God might make the universe ultra special. So, let's end up with a quote from George Demet. There were two ways. He was a bit of a Noma person, actually, I have to say, to Magisteria. He kept his science and cosmology largely apart, but he said there were two ways of arriving at the truth, and I decided to follow them both. And I'll stop at that.
Thank you, Rodney. That gives plenty of time for discussion, or questions, comments. Let's start.
I'm scientifically naive about the cosmological aspects you were talking about. How do people get a handle on what happened at 10 to the minus 42 seconds after the start of the Big Bang? Is that totally speculative or bordering on sci-fi, or how do they get there?
Well, I think two things are at work there, actually. One is that a theory which combines general relativity and quantum theory is required. And there are a number of theories on that. There's something called loop quantum gravity or so on, which basically the smallest kind of entity has to be something like that size because of quantum limitations. And so you get the need for a combined theory when you get down to that kind of compactness and that sort of early time. And you've also got very large gravitational fields, so you need sort of general relativity to take account of. It gets more and more speculative the further back you go. With the Large Hadron Collider of about a trillionth of a second, you've got processes that we think we know about. And so if they find the Higgs boson, well, that will be part and parcel of existing, that will fill in a gap in existing theory. As you go further back, the idea is that the forces of nature become further and more united. and everything becomes more symmetrical. But the theory does get more speculative. The inflation era is when you combine all the forces apart from gravity. You've got at that Large Hadron Collider instance, you've got the strong nuclear force left out, you get that one united further back, and then ultimately you get gravity united. Now, it is, I think, speculative. There are string theory and some other theories predict that there might be certain kinds of particle which would be found at CERN at energies we might be able to observe. I think so-called superparticles. So that would be some kind of handle. People I talk to don't think that would pin it down uniquely, but it's got to sort of interact with the lab at some point. The other thing about string theory is it's multi-dimensional. There aren't just three space dimensions, there are higher dimensions, but those are all compacted to very, very tiny, so we can't observe them. And of course, one of the issues is why we observe just the 3 dimensions we do, and why they've got compactified. Well, maybe they're getting compactified or not compactified, as the case may be in lots of other universes. That's the kind of argument. I think a lot of physicists think you're in the realm of speculation now. Martin Rees thinks it's science, even though it's he calls it speculative science. Others call it metaphysics, because there's no handle on the lab, which is what we'll ultimately need to bring it into physics proper.
Just right to the back first.
If I remember correctly, you showed the slide of Richard Feynman with his illustration of the car license plate and noted the contingent nature of his observation. And then if I remember correctly, the next slide was the car dealing machine, followed by a slide with the firing squad. And what I didn't really get was the explanation as to why Richard Feynman's explanation of contingency was inadequate. It seemed to me that it was more of an assertion that, well, the reason why I get a series of aces, or the reason why 15 sharpshooters missed, is either it was rigged or there's some purpose involved. And that sounds to me like an assertion. It doesn't sound to me like an explanation. So I wonder if you could tell me if I'm wrong.
I think it's because there is something about that particular pattern, or about my being still alive, given that I've been told what the rules were for me staying alive with the firing squad, that kind of requires an explanation. And into the bargain, there is a candidate explanation for the firing squad. And there is a candidate explanation for a very good explanation for the firing squad, and a very good explanation for the packs of cards and so on. With Feynman and his car that he saw, I would agree there's no need for an explanation of that. That's just the same as any other car. No particular reason to seek an explanation. If that car had was portraying some kind of message, like when I moved on to my old geography teacher, A.R. Wheeler, ARW, and with the birthday, 3rd of the 5th, 7, then for him, that would have a profound meaning. If that turned up on his birthday or something, that particular car would have a meaning. So I think the point I'm making is that this just isn't any old universe. I think the atheist has to press the case that this is really like any other old universe, that life doesn't have any particular value and so on, and that there's no objective value. That's has to make that sort of judgment. So that's, I think, how those sort of analogies work.
I have one just observation to make, and then a question. The observation, in case people aren't aware of it, and given the complexity of this field, there's a rather wonderful short novel just been published by Alan Lightman, a colleague of mine at MIT. It may not yet be published in the UK. It's called Mr. G. And guess what? Mr. G is God. And the novel portrays the creation of the world and of other universes in ways that I understand are consistent with the known physics, which is a hallmark of Alan Lightman's work. But it does it in a way that, for those of us who are not physicists, you can at least follow the plot. It has some rather unconventional elements, perhaps needed for dramatic license. It's told in the first person by Mr. G, God, who also has a cantankerous aunt and uncle, who are forever giving him unwanted advice about what to do. But I just offer it, if you can get hold of it, I recommend it. And it does interestingly play in a purely fictional way with some of the key ideas you've been talking about. That's the observation. My question is about your claim, which I confess I didn't completely understand, that the multiverse still needs fine-tuning. As I've understood it as an external observer, more or less the whole point of the multiverse is to solve the problem of fine-tuning.
Yes.
Why would one bother with such a profligate idea if it doesn't solve it, but just repeats it at another level? Could you perhaps go over again why, in your view, the multiverse still needs fine-tuning?
Yes, thank you. Thank you for the first point as well. That's helpful. And the other thing you might want to read on this sort of issue is, I think it's Jorge Luis Borges's books on labyrinths, and it speaks right into this multiverse situation with South American writer. Sorry, the point was...
fine-tuning in a multiverse.
Yeah. So the multiverse needing fine-tuning. I think there are two issues here. There is the which multiverse issue, and you can think of lots of versions of multiverses which are completely non-life-bearing. You can think of infinite sets which don't contain all possibilities, like the set 1, 3, 5, 7, 9, and so on is a set of infinitely many numbers which doesn't have the property of, none of which has the property of evenness, okay? So there has to be some kind of choice of a multiverse. And then the most popular kind of multiverse that is on offer is one in which there is an overarching infinite space in which the individual universes are different regions. Essentially, that's still true. That's true of the inflationary multiverse. Now, that needs this density parameter to be, for the whole thing, to be below the critical value. Now, a lot of other elements of fine-tuning are gone, of course, but it hasn't taken care of all of the fine-tuning, I think is what I would be saying about that. You need the overall density to be less than the critical value. And as John Barrow says, we can never tell what the overall value of the density is, unless we're in a relatively small sized unit. By small, I mean 40 billion light years or something.
Thank you.
I'm not a physicist, you may have to correct me if I've got some wrong information, but I understand that dark energy and dark matter, which are used to get the right answer.
Yes.
Am I right that the quantity of dark energy and dark matter have changed over the time period of the universe? And the second question is or similar to that, is that I understand there may be implications that some of these constants aren't actually constants.
Right.
And in that case, what would be the, if that's right, if not, just a very short answer, but if that is right, then what would you see as the implication of that on the fine-tuning argument? Because it almost would sound like an active tuning.
Yeah, possibly. So, dark energy and dark matter. Okay, now, the stuff we know about is 4% of the contents of the universe. That's ordinary kind of matter. There's something called dark matter, which takes up another 23%. And we know that that exists because galaxies would fly apart if it didn't exist. Okay, it's needed for the dynamics of galaxies. And that's so-called dark matter. And then there's this so-called dark energy, which is about the other 73% of the universe, and that's this cosmological constant. Now, over time, the density of matter thins out. The cosmological term stays constant. So in the present epoch, they're quite comparable. The two are the matter and the cosmological constant have come to take similar values. Okay. So that changes. But what's important, I mean, the critical value also changes with time, the critical value of overall energy. Which is why we always talk about a ratio of the total value of matter energy to critical value. Now, there are some theories which play around with the constants changing over time. I think they would have to change by very, very tiny amounts over time. And there are some modern theories about that. There are some older theories, people like Paul Dirac, who played around with the changing gravitational constant and so on. I think given that they would be over very narrow ranges that they have changed anyway, I'm not sure that it really changes much about the overall argument. But it's one of these things that's out there. People are playing with, cosmologists sit at their desks playing with lots of different models at the moment.
Sorry, in the way.
Hi, Rodney. Thank you for your talk. Hovering in the background of all these fine-tuning arguments is always the assumption that it's fine-tuned for human life. And I wonder whether you could sort of unpack that a bit, because at least superficially, this world seems very fine-tuned for bacteria, given that there's many more of them. They have lovely warm hosts like ourselves to feed on. So I think it needs a bit more work to prove that human life or consciousness is the ultimate aim of the universe.
Yes, thank you. For that kind of reason, Paul Davies now prefers the term sort of biophilic. It's a biophilic rather than anthropic universe. But nevertheless, and indeed most of these conditions are the conditions for anything complex at all, like galaxies and stars. And when it comes to life, it's sort of carbon-based life, the carbon production inside stars and so on. But nevertheless, intelligent life has evolved, the universe has evolved, and these kinds of conditions are necessary for us to be here. And they're even more special in the sense that if you were to vary these constants by a little bit, you might just end up with bacteria. You might not progress to complex life. You might not. One of the things Robin Collins points to Emacs is that the universe seems designed for human technology and discoverability. So when Newton came along, we could, if we'd been a planet going around a black hole or something, Newton wouldn't have had a chance of getting his gravitational theory off the ground. We'd have needed something much more complex, which we put into development. We needed to, and still, Newton's theory is great for getting us, out into outer space and so on, to the moon and so on. So the universe is more fine-tuned than is needed simply for even observers, so which it takes you beyond bacteria. So it's fine-tuned for something like intelligent life, able to understand it. If the cosmological constant were a bit bigger, we'd be in a living universe. The sort of thing Colin says is that, and this takes me back to the Penrose point as well, is that in fact, in a multiverse, we would be far more likely, if we consider ourselves as generic observers, to be something called Boltzmann brains, random collections of atoms that have come together and give us a view of the world which really isn't real. We've got an imitation world out there, and we're sort of, all we are is chance conglomerations of atoms which give a semblance of there being something out there. And then isolated, not able to relate to others and so on.
Do you believe that God...
Can you use the mic?
Did God tinker with the Big Bang regarding matter and antimatter? The imbalance there should have been an equal amount,
Yes.
should have been annihilation,
Yes.
but there's more matter than antimatter.
Yes. That's another of the fine-tunings, if you like, that there is just a fraction more matter than antimatter, so it doesn't all annihilate, and you just get a radiation-filled universe. Now, we may have, and of course, we may have a more fundamental theory which explains that. I don't think we've got that at the moment, but if we were to develop a more fundamental theory where there's some kind of asymmetry in the production of matter and antimatter, then what we call fine-tuning of those numbers, those quantities, would be moved into the theory. And we'd still have, I think, my view is that the basic problem never quite goes away. It gets moved from the fine-tuning of the in this case, the initial conditions of the amount of matter and antimatter to the theory that produces just that slight imbalance. So, yeah, that's another important one. Another important fine-tuning.
Rodney, if I could ask a question. Imagine that the various constants of the universe weren't as tightly constrained as we observe them, but there could be a range of values that actually exist, and which would still lead to a higher universe creating intelligent things such as us. My question is, how would the Christian respond to that observation? I mean, would they count that as evidence that God didn't exist? Would they say, this proves God exists because you set up a universe that would guarantee the emergence of complex life like us? So isn't it the case that we tend to interpret the evidence according to our presuppositions?
Well, if it were, if the constants were, the expression you used is less tightly constrained. I'm taking it that you still think they would be constrained. Now I take on board some of the problems that Stephen put there. This is this whole area is fraught with difficulty in terms of probability and the meaning of probability. That sure is the case. And whether you can apply probability distributions at all to these constants. And when I talk about, say, the density being fine-tuned because it has to be, below a certain value, well, we don't know what. We tend to just take the simplest of sort of uniform distribution as to what it could be, and there are lots of problems with that. So there are problems, but it does just look, however you visualize it, that there is basically a small subset of constants that gives rise to life, and certainly lots of values of the constants that don't. So there is a question as to why. It might weaken the argument, but I don't think that the overall design argument would be defeated by going down that route.
I think this is working. It's only a bit over 300 years since Isaac Newton published Principia, and we're just coming up to the centenary of Bohr's theory of what is called the old quantum mechanics. And in the last 100 years, physics has made an enormous amount of improvement, but it still leaves us with many, many controversies and unsolved problems, including this highly speculative 11-dimensional M theory. Cosmology is even a newer science and has even more uncertainties involved. But every time that science has pinned down some area from speculation and metaphysics into empirical ideas, theology has had to retreat. And I wonder if every time there is an uncertainty in science, theology seems to say, aha, there's the example of God in the universe. Are you doing the same thing?
Yeah, it's a good question, and I think some do shy away for precisely that reason. I think the sort of classic example is the William Paley style natural theology, which looked at structures within the biological world, and the eye and so on, and said, well, those have got to be designed. And I think this is different from that, because the question isn't quite the same. It isn't about individual processes within the universe, but it's about why the laws of nature take the form they do. I think we want to exercise some caution. I don't use the word, certainly don't use the word prove about this, but making the existence of God more probable and otherwise, that sort of thing. So yeah, a degree of caution. And of course I put theologians on both sides of this multiverse debate. If multiverse is the answer, then many theologians would be perfectly happy with that. So yeah, I mean, there's a right caution, but I think the question being asked is a bit different. It is a more metaphysical question.
I had a question, Bobby, just back here.
Oh yes.
A similar kind of thing, thinking about the theological implications of the fine-tuning. If it's not God of the gaps kind of feel, as you were saying, doesn't it feel a bit dazed?
Yeah, and that, thank you. That is a good point. How far does this get you? Is a point. And I think with John Bolton, I'd say that this doesn't get you very far towards the Christian God. I think one can make good arguments as to why one would go for one God rather than many gods, which has been raised. And I think that one God is much simpler. The fact that the laws of the universe are the same everywhere is more an indication of one God and so on. But it could be compatible with deism as opposed to Christian theism. So, I mean, I'm far from wanting to stop here. This is my day job at the moment. It used to be much more to do with preaching on Christ and Him crucified, which is far more central for me and what we're coming up to this Easter period. But nevertheless, I think there's something here. I think there's a good argument for maybe no more than Hoyle's super intellect, but something behind the universe.
We're increasingly hearing about how the universe, the Big Bang, was out of nothing. Are there any theories as to what that nothing is made of?
Well, yes, I think it's a mistake to say that the cosmology gives us a universe creating itself out of nothing, certainly, and that's the kind of expression that Stephen Hawking uses and Lawrence Krauss and so on, because what's really being talked about there is something like the quantum vacuum. The vacuum sounds in everyday language to be nothing, but in fact it's space full of quantum fields and all that kind of thing, and particles continually being created and annihilating and so on. So that doesn't give us cosmology doesn't solve it by giving us creation out of nothing. I think that's a mistake. It's not the philosopher's nothing that they're talking about there.
Okay, I think, when we start talking about nothing, it's time to think about dinner. Because dinner's very nice, not because dinner's nothing. So thank you, Rodney, very much. We'll pause now. I think dinner's at 7.